boys and girls, we're going to start reading our student reader for Unit 6, Energy Transfers. And you can see that this boy and girl is on a seesaw. So it says the front, and we even have a caption. The front cover shows two children playing on a seesaw. Seesaws are a kind of lever. Levers, or levers, are a type of simple machine. This means they redirect force so that it's easier to do work. For our table of contents, we're going to be working on Section 1, Doing Work with Machines. Sewing for football players, forces on Earth, simple machines help to work. Simple machines redirect force, and we've learned about simple machines already through our work on our learning menu and Google Classroom. Changing the motion of a seesaw, scissors use simple machines, in the know, simple machines all around, and then we'll be able to complete our lever investigation. So let's begin. Doing work with machines. Sewing for football players. Margie Switzer sews many football jerseys. Marge is the seamstress for the Green Bay Packers. The Packers are the football team of Green Bay, Wisconsin. Marge has a sewing room across from the locker room. One of her jobs is to mend the players' uniforms. She fixes rips or tears that occur during the game. As a seamstress, Marge uses different tools to help her do her job. One tool is a good pair of scissors. Many people don't think of scissors as machines, but they are. In science, a machine is any device that does work. Work is any change in position, speed, or state of matter due to force. So those are two very important things. Because a machine is any device that does work. That sounds like a definition. And work is any change in position, speed, or state of matter due to force. That also sounds like a definition. And we have our photograph of scissors and our caption. Scissors are a kind of simple machine. Forces on Earth. Remember that a force is a push or pull that acts on an object. Force is always needed to transfer energy into or out of a system. Gravity is a kind of pulling force. Gravity is the force of attraction between all matter. On Earth, the force of gravity pulls all objects near Earth's surface down. So again, those are definitions. A definition of force, it's a push or pull that acts on an object. Gravity is the force of attraction between all matter. Gravity is why a football thrown by a player will fall back to the ground. It is also why we don't all float off into space. Friction is another force that slows motion whenever two objects rub against each other. Friction slows motion because it causes some of the energy of the moving object to change into heat, like rubbing your hands together. And here's a photograph of a Green Bay Packer and the caption, "Gravity pulls down on this ball, causing it to fall to the ground." Simple machines help do work. Now this is review. You had a friction activity, you had a simple machine activity, so you had a force activity. So hopefully this is sounding somewhat familiar. To understand how scissors use force to do work, we need to begin with their structure. Scissors are made up of two smaller simple machines. Here's a definition. A simple machine is any device that helps us do work by redirecting force. We'll use a seesaw to explore this idea further because seesaws are similar to scissors. Both seesaws and scissors use levers to do work. A lever is a simple machine that is made up of a stiff beam that rests on a support called a fulcrum, and you can see that in this diagram. The beam is called an arm. So you can see here in this photograph, it's a seesaw. The seesaw, the board, is the arm. Where it pivots is the fulcrum. Scissors are made up of two levers. Seesaws are one lever. They have a simple structure. A long, narrow board is supported by a fulcrum in the middle. Simple machines redirect force. Levers redirect forces because as one side goes up, the other side goes... Whoops, I did that backwards. Levers redirect forces because as one side goes down, the other side goes up. Again, let's look at a seesaw. The seesaw's arm rotates on this fulcrum. This movement is called a pivot. Let's explore this idea a little more. Imagine if just one person sits on the seesaw. The seesaw will be unbalanced. The weight of that person pushes down on one side of the seesaw. The seesaw redirects that pushing force to the other side. This causes the seesaw to pivot on the fulcrum as the other side moves up in the air. We're using weight rather than mass here because we're talking about forces. Remember that weight is the gravitational force exerted on an object by a planet or moon. Weight is calculated by multiplying the object's mass by the force of the Earth's gravity. That's a little complicated. But remember that weight is the gravitational force exerted on an object by a planet or moon. Changing the motion of a seesaw. Now imagine that a second person joins the person already sitting on the seesaw. This second person sits on the other side of the seesaw. The motion of the seesaw changes depending on the weight of the second person. And look at this photograph. If the second person is a similar weight to the first person, the seesaw will be balanced. See how this is balanced? They must be about the same weight. And the people are an equal distance from the fulcrum. Remember that forces are acting on an object are balanced when they are equal. To make the seesaw move, there needs to be an unbalanced force. This happens when one person applies a force by pushing down on the ground. This downward force push is called the effort force. The effort force is the force that is applied to the simple machine. So think of it as your muscle is your effort force. That effort force transfers through the seesaw to do work. The work it does is lifting up the other side. See? The person being lifted is the load. They're lifting up a load with your muscles. A load is an object that a simple machine moves, or the force that the simple machine must overcome. So it could be a box. The seesaw can be fun because people on the seesaw take turns applying the force and being the load if you're different weights. What if the person joining the person sitting on the seesaw is an adult and the person on the other side is a child? The adult will weigh more than the child. Because of this, the adult applies more force to the seesaw than the child. This makes the seesaw unbalanced. The child won't be able to lift up the adult. In order for the seesaw to move, the heavier adult would need to move closer to the fulcrum. See how the adult is closer? This would change how the forces are applied. It would allow the child to move the adult using less force. So it depends on how close you are to the fulcrum. When the child pushes down on the ground, they apply the effort force. This means the adult is the load. As the distance between the adult and the fulcrum gets smaller, the child needs less effort to lift the adult. If the adult was on the very end of the seesaw, the child would never be able to have enough effort force to lift the adult. But if the adult moves closer to the fulcrum, the child will be able to lift them. It's important to remember that energy cannot be created or destroyed. This means that levers don't create energy to move heavier objects. Instead, they allow the work to be done with less force by increasing the distance that the force has to travel to do the work. This means that the same amount of work gets done. The lever just makes it easier to do that work. We can understand this with a hammer claw. The claw of a hammer is a lever. It works by redirecting forces so that less effort is needed. It helps pull nails out of wood much more easily than could be done with your bare hand. Unlike the seesaw, the fulcrum isn't in the middle of the lever arm. Instead, it's close to the side of the hammer that does the work. The closer the fulcrum is to the load, the heavier that load can be lifted. So see how close the claw is to the nail? That's why you can pull it out more easily with less effort force. Scissors use simple machines. Now let's go back to the scissors. Scissors can cut different materials because they're made up of two levers. Each lever, boink, boink, is a metal blade. This blade has a sharpened edge, and they are joined by the fulcrum in the middle of the scissors. The scissors work because as you move the two handles together, you apply that force, that effort force, that goes to the fulcrum that crushes the load. The scissors redirect the effort force from the handle to the blades. This causes the blades to move, producing a load force. When the sharpened blades slide against one another, they cut whatever material is between them. So when you look around, chances are you'll see a simple machine. Every time you go up or downstairs, which we do when we go to lunch, or up a ramp or down a ramp, you're using an inclined plane. So an inclined plane is a slanting surface that connects a lower level to a higher level. It's easier to raise or lower a load when you use an inclined plane or a ramp, right? Rather than lifting or picking it up and putting it down. It's easier because they increase the distance that you need to travel. So the longer the ramp, the easier it is. And when you pull a suitcase or push a shopping cart, they move because they use wheels and axles. An axle is the rod that goes through the hole in the center of the wheel. As the wheel turns, it turns the axle. If the axle is attached to an object, like a suitcase or a cart, the wheel and the axle make it easier to move the object. They help to reduce friction. Have you ever kept a door open using a doorstop? Or dug a hole in the garden with a shovel? If so, you've used another kind of simple machine called a wedge. A wedge is a triangular tool. It has at least one slanting edge that ends in a sharp edge. It separates or holds objects in place. And if you've ever helped to put together furniture or toys, you've used screws. A screw is an inclined plane wrapped around a pole, and it holds things together or lifts materials. Finally, anytime you've ridden in an elevator, you've moved up and down because of pulleys. A pulley is a grooved wheel that raises and lowers or moves a load. Pulleys are how window blinds and draperies are opened and closed. And that is the end of section 1. If you're listening to this, you're now going to have a Google form to answer some questions about this section. When you come back to class, you will be performing the lever investigation, and we will be doing that in class, and we'll be explaining it to you. So for the section 1 review, we may not use these exact questions, but you will have a Google form that will ask you questions about this section. If you want to have 2 tabs open, you can try to answer the Google form questions and come back to this student reader section. Thank you.